Wow, that was very boring. uh, okay, so hopefully this is interesting for you. So the general layout. I'll start with architectural. There's not the general layout is I tried to keep it to where originally I was going to try and use 2x12s to support the roof and first floor, but I came to the conclusion that would create such a long and narrow house that it wouldn't be very probably wouldn't use the land the area really well, and it just wouldn't produce a good layout. So I ended up deciding to go with some engineered trusses and engineered I beams for the roof and second floor framing, and that way I could increase the width of the house. The whole concept was to keep as many south-facing windows as possible. Just so you know, this is the north arrow. That's the standard one created by Revit. It doesn't really look like a north arrow, but not that I'm used to at least. But that's what it is. Just in case you're wondering. So one of the critical things, of course, with this design is the orientation of the building. So you want to have north as a page up. So you definitely want to keep north that direction. That's not a very good end, but anyways. So that's the basic concept. That's called a passive solar design, to where you have more windows on the south face than on any other face. But you know, if you read, there's a reference from Green Building Advisor, and honestly, they said that when it comes down to it, passive solar doesn't work extremely well, because if you have so many windows, too many windows, it gets really hot in the winter, and also windows out of this whole design, all the walls and everything, the windows are your thermal bridges. By thermal bridge, I mean that's where your energy, your heat, and cooling escape the building. They're through the doors and windows because they are the least insulated part of your building shell. So, really, reducing the quantity of windows and doors is the best way to go, as opposed to having southern facing solar windows, a large quantity. So in the end, I decided to reduce the quantity of windows, but the quantity, and just to put the windows. This was based on I've got a link to the Green Building Advisor where I found this post, and I tend to agree with the general concepts of that write up after doing years and years of research. That it's best to just put the windows where you want them and try and reduce the quantity as much as you can. And you know, an added benefit to reducing the quantity of windows is you reduce the cost of the construction as well, because windows and doors are expensive. Okay, so another layout that you'll see is you'll see that the east side and the west, well, the east side and the west side of the house are mirror images of each other. That was done intentionally because in the future we may want to turn this into a duplex. I mean, we may or may not live here our whole lives. We may or may not have, you know, adult children that want their own apartment next door. We may or may not have in-laws live with us. You know, you never know what the space is going to be needed for. So you can easily just tear down this middle wall that's a duplex division wall and turn it into a one story house, or a you know, a one family house, a single family home. So that's why it's separated the way it is. Got 2 bedrooms on the west with closets, and then I call it a multi-purpose room because it's a kitchen slash living room. And it may end up being, if you live, it may end up being an office on one side and a living spaces on the other. And then you got the centralized bathrooms and utility rooms. Another way to reduce your construction cost is to group all of your kitchen anywhere that there's water. Your kitchen, your bathroom, your utility rooms, anywhere that you need water. If you group those together, it after years and years of experience, it's just easier to build it, maintain it, remodel it, everything. So that was the reason why all of the utility rooms are grouped together in the middle. And then, of course, on the east side, you've got 2 bedrooms and a multi-purpose room. You'll see here that this is the basement. I added a basement to go. Originally, I just wanted to do slab on grade, but I thought better of it. It does increase the cost, and there's not getting rid of the basement would be one way to cut the cost if you did want to cut costs. Because you always have to look at that, but it does increase the functionality quite a bit of the house. It can double as a storm shelter, and also it's a place to run all of your utilities, your sewer, water, and have the water heater, and also all the electric will be downstairs, all the electric panels. And if you did want to do battery storage in the future for solar, that would be a place to put your batteries. It's just a good utility place. And then, of course, you got a room schedule. So house ended up being a little bit bigger than what I had planned on, but you can reduce this, of course, easily. It's no big deal. So the basement's 400 square feet. The east duplex is 1,000 square feet. The west is slightly smaller. I did have to offset the separation between the two in order to have a trap door down to the basement. And then you've got, I went ahead and designed this with an unfinished attic that we could later on create a finished, another duplex upstairs. So theoretically, this structure could be a quadplex, a duplex, or a triplex, or one single family home, depending on how you wanted to set it up. And that's why I set it up the way I did, kind of mirror images of each other. To keep the cost within our budget, I did have the second story be an unfinished attic. So as you can see here, it's just an unfinished attic, so it'll be a huge storage space until we can afford to finish it. Of course, this is your roof layout, nothing special here. You have to check your residential code. It's really important that whenever you do anything, you always want to follow the code requirements, and they vary from location to location, city to city, state to state, jurisdiction to jurisdiction. So always check with your local code requirements, because you don't want to build something just to have them tell you can't live in it or that you have to tear it down. So that's before you build anything or buy any land or do anything, you want to check your code requirements. One of the code requirements is to have lap ceiling. Originally, the slope of the roof was higher, but due to the restrictions in the code, I decreased the slope so that the heights between the floor and the roof would not be so great that it would require additional bracing, horizontal bracing for the CMU walls. So it's better to have a higher slope on your roof for drainage and for snow buildup and everything, but in this instance, it worked best to reduce the slope in order to reduce the bracing requirements. There's probably ways to get around that. So if anybody has any comments or recommendations, I'd love to hear any recommendations, especially from contractors and other designers. So feel free to leave any comments or anything that you do have. Please keep them constructive, though. So you have to install lap sealant on the roof metal panel joints because of the slope of the roof. That's a code requirement. And then it just you have to install underlayment. There's nothing new there. So this is the furniture layout. Nothing special here. You can adjust this however you want it, really. We went with sealed concrete. This area here, the west and the east rooms are all just slab on grade, and then the middle section will have a wood frame floor with either vinyl or ceramic tiles. And one of the reasons, so if you're wondering, one of the reasons of having all this concrete, if you notice there's concrete block walls and there's concrete floors. So one of the reasons is to do that is a concept of thermal mass. So of course when a mass is heated or cooled, it stores that energy. So and it takes, and every different type of mass, whether it be water or concrete or air or plastic or whatever it is, has a different energy density. So the energy density is how much energy that object can store, and concrete has a high thermal mass. Water has one of the highest ones, but I didn't really want to make the floor out of water, so we went with concrete, and also it's pretty structurally sound. So a concrete floor, 4-inch slab on grade on both sides. That's about as thin as you probably want to go with concrete. You could go thicker, but your cost will go up. And then CMU walls. The CMU walls had multiple purposes. One is it's a structurally sound material. And I tried to go with common building materials. You'll see when we get to the estimate portion that all the materials are available at any home materials store, your building centers, your Ace Hardwares, your Home Depots, Lowe's, Menards, all of them. You can get all these materials at most of those stores off their stock, off the shelf. So that was another concept. I wanted to go with stock items so that any Joe could go to the store, get these materials, and build this house. It wasn't anything specialty, and most of these don't require, of course, laying block is a skill, but anybody can learn it just about. So that was one of the reasons. So that's another reason for going with CMU, but also because it's structurally sound. So, in the event that there was a tornado or hurricane or, something, then the CMU walls would hopefully protect you somewhat. And also they last, you'll notice a lot of structures that the roof's gone and the walls are, and everything's gone except for the CMU walls or those stone walls. So they tend to last pretty well. So it's got good longevity as well. So, and they're easy to maintain. The interior walls will end up just being painted CMU block, similar to what you'd find in an institutional structure like a school or something like that. They're easy to clean. They're not much maintenance. One concept you want to make sure is to caulk every joint, every penetration, every hole that you find in those CMU walls. That way you keep it airtight. Airtightness is an important concept for passive house and to reduce your energy consumption. Well, your biggest consumer of energy, if you don't already know, is going to be your HVAC system. to heat and cool, specifically the heating system in the region in central U.S. Provided, plywood around the windows that'll be sealed, and then polyurethane finish. Trapdoor for the basement. I always hate putting in stairs because it eats up your floor space. So with a trap door there. And then got some casework drawings. These are going to be subjective, whatever you really want to put in there. And then a closet detail for the closet and your casework. And you got your fan coil unit up here, one with a split system for the fan coil units. Of course, we'll get to the HVAC in a little while. These are just some elevation views. So when we get to the estimate portion, you'll see that the base, I set it up into like 11 different phases for the project because I wasn't sure what our budget was going to be like. And we'll get to the phasing portion, but you'll see in order to get to the second story, you'll end up having to put in some stairs, unless you want to use a ladder. Of course, you could always just use a ladder if it was just storage or something, but it's easier with stairs. And you'll see the solar panels are out front here on the southern side of the house, of course. And the reason for doing that was twofold. One, of course, you want to put the solar panels on the south side of the house to get the sun. Well, at least in the northern hemisphere, you want it on the south side of the house. But also, we'll get to this portion as well, but these braces for the supports are adjustable. So in the summer, you can adjust it up to collect more sun in the summer, and then adjust it down in the winter to collect more sun in the winter. That's one area I may want to look at putting in instead of doing this, maybe just putting in a immobile support and have it permanently angled towards the southern solstice, because when I was doing my research, it didn't seem like the angle actually made much difference. And of course, in the summertime, you don't really need that extra electricity. Of course, if you got it, it'd be good to produce it and then just pump it back out on the grid, and either you'd make some money or at least make a donation. So one thing I did find was that I didn't realize you had to put in an escape window if you have a basement. So that's the escape window there. Makes it kind of difficult for the insulation of the basement, but we can make it work. Of course, some section views here. One thing to remember is that you need ventilation for your insulation, your attic, and in order to provide that ventilation, as you can see, the design I came up with has no soffit. So to keep everything simple, I did not include a soffit. There is an overhang here, but it's an overhang. You'll see this cavity here is for insulation. So I guess I probably should have covered that a long time ago, but the ideal is to have the interior thermal mass and then exterior insulation, and in order to protect that insulation, I've got metal siding and a stud wall to protect that insulation. And in order to ventilate the attic insulation, I introduced the ventilation down at actually the foundation or the ground level. And so I plan to leave a 1/2 inch gap between the sheeting girts and the sill plate for that wall, and then the air will just travel up through this stud wall into the attic space and then out the ridge vent. So leave the stud wall clear for ventilation. And then, of course, you want to include an insect screen down there to keep any rodents or insects out. And then of course I put to seal the sill plate, and you want to seal every crack. Also, you want to seal that crack there. Now inside, I went with a removable drop ceiling. That way, in the future, especially for the bathrooms, if we do finish the upstairs, to get to all that plumbing, and that's also where all your wiring will be ran for all the electrical. So, in order to get there, you're going to need to get up there, and I didn't want to put a drywall, so I went with a removable drop ceiling for future alterations. I decided to go with actually a Luan, and you can get Luan in 2x4 sheets, and then just do a standard aluminum grid, and then just pop that Luan up there, and then when you need to get to your utility, you can pop it back out. If you have any questions or anything or any comments, feel free to post them. I'd be glad to answer them, or I'll try to. I may get busy and not be able to. You never know. And then another note is to slope your slab away to the exterior, because you don't want that water running into the interior of your house. Now, one common theme you'll see is insulation on this house. So with passive house and passive solar and energy efficient housing, you want to have lots of insulation. So one important thing is to have insulation on all your perimeter walls. So I'm not sure what happened here. Let's look at Revit and see. What sheet was that? A301, I think. So sorry about the slight delay. Okay, it looks like the insulation disappeared in this view, but it's here now. Why isn't it in that view? Anyways, so if you insulate here, you want to decrease thermal bridging. So concrete is a good conductor of thermal energy. So you don't want to have any openings to the exterior that are not insulated, or you don't want to have any thermal bridging. So you want to have insulation fully encapsulating your entire structure. So here I decided to run the insulation up to the floor level, and then you have an exterior slab. Really, it's just to hold the insulation in your exterior wall. And then you've got insulation below your slab and on the interior of your stem wall and on the exterior of your stem wall. The insulation is just R10, so it's nothing special. You can get it at Home Depot. And then, of course, insulate the exterior of your basement and below your basement slab as well. And then, of course, the metal siding manufacturer. You want to check with your metal siding manufacturer and see what they recommend. But the one I looked at recommended having a 6-inch clearance below the finish grade, or above the finish grade. I don't know why the insulation didn't print there, but for some reason it didn't print. A couple more section views. If you're still with me, thanks for hanging in there. I'm sure to some people this might be interesting, but to others possibly not. If you just want to go and download all the data and go through yourself, feel free. It's probably a little easier that way. So of course there's all these notes here. This is the engineered truss, and of course these are I-beams that are running through the roof here. These are your solar supports. Another important concept with passive solar is that in the summertime you want to block any sun from coming in your windows, but then in the wintertime you want the sun to come in the winter. That's why I show the winter solstice path. And also that goes into play with the adjustable solar panel angles, because in the summertime, as you rotate them out to capture more sunlight, it also has the double effect of it blocks the rays from going in your windows on the southern side of your house. So it has a there's a dual purpose to uh, mounting them on the south side of your house, and also I don't really like to mount them on the roof because it makes them difficult to access, and you do have to maintain those things. You clean them and maybe check, maybe get a short every now and then or something. Have to check your wiring, but I'm thinking maybe I'm not sure about the rigid support that's immobile, but so as far as the insulation goes, I had planned to have straw for insulation. I'm still on the fence about that, but 18 inches of straw provides an R25, and that's why these cavity walls are so wide on the outside. It provides about an R25 on average. Depends on the straw you get and everything, the actual R value, but there's a dual purpose or multiple purposes. One, straw is inexpensive. And from what I read, it's not really as flammable as what you would think, especially when it's densely compacted. And then it's a good insulator, and it's also a locally available material. So I was looking at getting LEED certified for this building, but I haven't really done that much research. It was going to be a decent process to do all that, so I've not done that. But it could probably be LEED certified as silver or gold, maybe even platinum. I'm not sure, but I'm almost positive it would reach silver. I did look at some of the requirements, but it looked like it was gold to me. But anyways, I'm not really a LEED expert, so I'll leave that to you guys if you want to do that. But the installations are R25, and one of the requirements for LEED is to buy locally produced, locally sourced materials. So if it's straw and it's just from right up the road, then not hay. You don't want hay. Hay has materials in it that will decompose, and you don't want hay. You want straw. So one cost reduction possibility would be to eliminate the straw and put in just R30 or R38. I think I put R38 here, but you could go with like R30. You could probably even go with a lower R value of insulation and still meet all the requirements for a passive net zero energy house. So and then of course make sure there's a 1-inch gap. I went with 16-inch I-beams and 16-inch members for the floor because it was actually cheaper to go with 16-inch because you can space them further out than the 14-inch that I was looking at. So anyways, make sure and leave a gap for your insulation ventilation, so the ventilation will come up through the walls and then up across the roof and then out through your ridge vent here. So insulation that I'm calling for is R49 with an R13, and then on the inside surface put an R13 insulation board, polyisocyanurate board, and then cover that up with drywall in order to get your fire rating. Because polyiso, I guess, is slightly flammable and slightly there's a smoke spread index and a flame spread index, and it exceeds that for use in a plenum space, so you have to cover it up with drywall in order to get your smoke and flame spread index or something like that. I'm not really sure. This is just a section view of the escape window from the basement. You can see you've got your outside air intakes. We'll get to that at another point, but we've got an earth air heat exchanger, outside air intakes. This is another section view. You will have to provide some reinforcement in your concrete where it passes over this window well here. And of course the insulation here will need to be covered with concrete. I'm using concrete fiber board with a stucco finish. That's just to protect the insulation. And then this is the stairway. Here's your escape window and basement stairs. You need backflow preventers on yard hydrants. I went ahead with yard hydrants because I didn't want a pipe to penetrate those above ground walls for hose bibs on the wall, because the walls are thick, and then I just wanted to reduce the amount of penetrations above grade. Unfortunately, you have to add a backflow preventer because those valves, stop and drain valves, are not considered sanitary. So, and then a trap door, that'll be interesting. I'd like to see. I'm gonna leave that up to the carpenter how to do the details for that. Found this really nice detail on, I think it was uh, either energy.gov or National Renewable NREL.com, National Renewable Energy something.com. This just shows the general concept. And then I found this neat ridge vent and just detail, just Googling, and I thought this is going to be similar to what we'll end up having for a ridge vent. So they call this roof type a shed roof that slopes one direction. So because it's commonly used on sheds. The only disadvantage I really thought to having a roof shape like this is that they're not supposed to be the best for high wind areas, so you might want to check your requirements. And of course, we'll make sure and have strapping down from the concrete to the I-beams that are running through the roof, because in high winds, those roofs can be an issue. So if you've got really high winds, you might want to look at a different type of roof structure. Just another comment on that roof structure. There's multiple reasons for going with the shed roof. Number one is cost. It's supposed to be the least expensive roof to build, probably because it's just straight beams across. And there's not much to it. You have straight beams across, and then you just it's all one direction, so you just lay down your metal siding. It's easy. There's not a bunch of valleys and peaks and everything. Another reason was because there's not a bunch of valleys and peaks. Those are places where roofs will leak. Architects like to. I shouldn't pick on architects, but architects like to add them because they had architectural appeal to the house, but they also are a place for leaking, and they're also more expensive to install. And then another reason, I guess the last reason I can think of off the top of my head, there were probably other reasons, but the last reason is because the slope. The design incorporates a rain catchment system, so if all the water slopes to one side, then you just have all your downspouts on one side, and you have one pipe that goes through and collects all the water and takes it to your central cistern. And so it's easier to design your storm drainage system to collect all that water. So here's an idea of what the window area will look like. The windows are one area that are going to be the least energy efficient. So with passive solar, you want to go with the highest solar heat gain possible. So at least for those southern windows, we want a high solar heat gain coefficient of 0.6 or higher. Those aren't often available. In the U.S., I've found, because of energy code requirements, and a lot of U.S. houses don't incorporate passive solar, so you might have to shop around to find those windows. And in the end, I'll probably just go with what I can get. But if you can get some highly insulated, like R5 or greater, and high solar heat gain coefficient, that's what you want, at least for the southern windows. Now the northern, eastern, and western windows, you just want windows that actually have I wouldn't say a low solar heat gain coefficient. Yeah, I guess a low solar heat gain coefficient and high insulation. The insulation value is the most important. One way I don't know if I mentioned, but changing out from straw to fiberglass. That's one, not only cost savings measure, but also maybe feasibility. If you don't have straw, inexpensive, good quality straw readily available, then reducing that cavity and changing to fiberglass insulation would be a possible uh, positive change to make. It would reduce the cost. You might reduce the cost several $1,000s. So I'll probably look into that when it comes time to build. And then we've just got all our schedules here. I won't go through all these, but these are your casework, roofing, windows, doors, walls. I kept them floors. I kept them fairly generic. The floors, I was going to just do slab on grade for the floors and just put a standard, just a clear finish on it. They do make some really nice colored finishes, so when it comes time to build, I may look at that. Be nice to have some nice brown polished concrete floors, maybe. And then this is generally what it'll look like from the outside here. Nothing special, it's just of course we've got different phases. I'll go over that later though. Then we got our civil works. Since I was planning for this to be semi off grid, I went ahead with a septic tank. I was going to try and reduce all the bills. I was looking at the cost of bills and everything, and it'd be nice to not have any utility bills. I thought, that way it's all up to me. So we've got our septic tank system over here. You may end up hiring a separate contractor just for that, because there's often contractors that specialize just in septic systems. There's not much to them, but there probably is a lot to them, but it's not too difficult to figure out if you want to read the codes. There's the International Private Sewerage Disposal Codes. And then we've got our cistern over here. Of course, you can see I put the two opposite sides of the house because you don't really want the waters mixing. So you can see all the stormwater drains over to the cistern, and then all of your sewer drains over to your septic tank. And then of course drainage you got a drain to your cistern, an overflow and a drain. Actually, no, I don't remember actually seeing an overflow in the cistern. But anyways, you got an overflow and then a drain. Oh, this is just the overflow. There wasn't a drain. I'm not sure how you're going to clean that out. But anyways, we'll worry about that later. You want it to, if you're on a hillside, it opens up to I meant to add a detail for a dry well. But anyways, you'll either have to add a dry well or a seepage bed or something if your site doesn't slope to drain. And then let's see, this is civil. Oh, I included foundation drainage. You may or may not need it depending on your site conditions, but I went ahead and put it on here. That way, if you do bid this out, that the contractor will include it. Or if I bid this out, the contractor will include it. And there's two methods of getting rid of the water from the foundation drain. You can either go to a sump, which is you probably you could argue which method is better. Of course, it's probably always better to daylight any sort of a drainage system. So again, if your site has slope, you can slope that to daylight. And then we got the electrical. All right, we're getting into the fun stuff here. These are just general notes and everything, general legends. Those are from past projects, so they may or may not really apply. Just throw them in there. Nothing really special here, It's just electrical diagram. Shows where all of your fixtures and switches and receptacles and everything are. Want to keep in mind you need a local disconnect for your condensing units. Looks like I forgot to tag that one. And then we got wall packs up on all of our walls. I included a CCTV system. then you got your reflective ceiling plan, shows all your lighting and everything. Not really anything special here, you know. Got smoke detectors everywhere, one in each room, I think. Here's the fun stuff here. Let's see. This is our one-line diagram for the exhaust fan. I was wondering how to get the air change rate, get the the vent, because with passive house requirements, you can only have a certain air leakage rate for your building, either into or out of your house. So I set up a motor operated damper for the outside air intake for the earth air heat exchanger, and if there's any electricians, let me know if this will work. I'm not positive if this will work really well, but it's one motor operated damper connected to 4 double pole switches, and it's all on one circuit, so you're not going to be backfeeding another circuit, so you're not going to have like 40 receptacles on one circuit, but you will have 4 double pole switches connected to one motor operated damper. I'm curious to see if that'll work. There's other ways to do it. I was just not going to put any damper at all, or just have a backdraft damper, but that won't work. And if you have infiltration or exfiltration of your air, if the air's going both ways, it'll only block the air from going out, not from coming in. So when you do your blower door test to test your air tightness of your house, it would fail. So without a motor operated damper that would keep it closed, unless of course if you gagged it or something. So this is our solar array. We got 9.36 kW solar arrays, what we figured we need for the solar. Decided to go with a hybrid solar inverter for multiple reasons. Just in case we want to do future battery storage, and they also have some different requirements. You can, with the hybrid solar inverter, you can have like a separate panel for critical load, so if the utility power does go out, you can still power just a few loads from that inverter, like maybe your fridge or something, just that way your food doesn't spoil. And I went ahead and set the power up so that in the future you could have 4 separate loads, one for each separate apartment, if you did end up separating it out into a quadplex. It's pretty easy to do it on the front end. If you have to rewire it all later, it would be a pain. So a couple $100 extra to add in an extra panel, it seems like a decent ideal. And then of course you got your main panel coming in. It'll be a 200 amp main panel, and then your utility connection, and then 100 amp panels for each of the separate apartments. And then just a standard detail for your mounting heights. And then of course all your schedules here. I kept everything generic, that way, if you're shopping at Home Depot or Lowe's or wherever, Menards or wherever you're buying it from, that way you can always find, because it's all going to be different brands, so long as you find the same, as long as it basically adds up. Of course, downstairs you want to have all GFCI receptacles. I went with 390 watt solar panels. That was about as big as I could find, because we can only fit about 24 on the front of the house. So I went ahead and went with 24 with the highest wattage that I could find that are readily available. And cost-wise, it doesn't really make much difference if you're looking at dollars per watts. And then you've got your power panels, your hybrid inverter, your light fixture schedule. And then I went ahead and put together a low panel schedule for your 2 power panels. Where are we? What happened? I got lost. Okay, and then I went ahead and put together a power panel schedule for both of your panels and labeled each circuit with the corresponding letter. if you see, I'm not the best electrician in the world, so or electrical engineer, or whatever. So if you see any issues, be sure to let me know. And then just the general sheet that talks about the general concepts. And now we get to mechanical, your HVAC. I have an energy model that I put together using eQuest software. I've included that in the downloads. So eQuest is a free energy modeling software. It's not the best in the world, but it's not the worst. It gives you a good idea. I also modeled it using Manual J from ASHRAE, which I think is a little bit more accurate. And we're somewhere in between the two on the sizes of the equipment, so it should work out. One of the good things is that from eQuest, it gives you your approximate usage for the whole house, for your energy consumption for the whole house, which is kind of nice to have when you're including a solar system design, photovoltaic solar system, designing a whole solar system here. You just got some fans and condensing units here. The size of the split systems that I've got for the house are 2-ton units, 24,000 BTUs per hour, high efficiency. You want to go with high efficiency appliances for everything in order to minimize your environmental impact and your energy usage, and to get the most out of your solar power design, your solar system. And also, if you did go off-grid or battery storage for your photovoltaic system, you'd want to minimize all your energy consumption. So got duct schedule, duct fitting schedule, air terminal schedule. So for the upstairs, I just included a duct from the base. Well, actually, there's 2 ducts because I couldn't fit one. So somehow you'll have to get the outside air up to the 2 apartments, the 2 future apartments, and it's easiest to install that duct when you install the first floor. So you want to go ahead and include that in the preliminary or the first phase if you can. Okay, and then ventilation concept on the first floor is pretty simple. I'll just look at the western apartment. So you have, of course, an exhaust fan for your restrooms, and you have an exhaust vent for your dryers, and then this is a transfer grill. So all the outside air is coming in through your earth air heat exchanger into the basements, and then when you turn on either exhaust fan 1 or 2 with that switch that's connected to the motor operated damper, the motor operated damper will open and the air will come through your earth air heat exchanger into the basement, through the transfer grill, underneath the door for the utility room, because the doors are going to be undercut to allow the air to come up into your multi-purpose room and either be exhausted through exhaust fan 1 or 2. I didn't put a transfer grill in the bathroom because I figured you probably don't want that in the bathroom. And then you'll have to undercut also your bathroom door so that the exhaust air can go, the outside air can go up through your bathroom as well. For heating and cooling, like I said, we got a 2-ton unit for each apartment, and when you add if you add the 2 apartments upstairs, you'll need 2 more heat pumps for those. These are heat pump units, standard from Home Depot, Lowe's, wherever. And then for the ventilation, in order to get that air circulating, I added some fans to supply the air to the bedrooms, and then you got transfer grills back. The reason I did that is because you might want some privacy, So if you have fan and duct, that way you don't have to undercut the doors and hear everybody's conversations. And of course, the same concept for the other side. there's multiple different ways you could do this, but I thought that would be one of the easiest ways. You could have a fully ducted system. That would actually probably be a pretty good option as well. But that's the route I decided to take. And these are just some section views to show you. This is a section view here of the basement, and this is where you have your outside air coming in from the underground, and it transitions to metal duct, and you have your motor operated damper that will open when you turn your fans on. And of course, one important thing to do with your outside air is you want to slope the pipe in case you get condensation, which you most likely will in the summer months, and then have a drain on your pipe as it enters the wall that will go to a condensate sump pump that can pump it to the sewer system. And here you can see we also have condensate from our water heater, our heat pump hybrid water heater. I probably should have included the pipe on a plan view, but anyways, it's shown on the plumbing. I'm not sure who will end up installing that. Probably the plumber, and then the HVAC will install all the ductwork. This is just kind of an isometric view of the overall system. One thing I did include was also a radon vent. Depending on your region, you may have to worry about radon gas. So this radon vent it goes here below the western slab, it goes here below the eastern slab, and then it goes here below the basement slab, and this is a passive radon vent system. So it just exits out through the upper wall of the house. This is you can find the details for this in an appendix in the International Residential Code. And if you didn't know, the International Residential Code is available online for free from ICC, the group that produces the codes. So you can get on there and you can look at all the international codes anytime you want: plumbing, residential, mechanical, fire, building, any of them. So on to plumbing. Boy, this video's gonna take a long time. We're about the 1 hour mark. Hats off to anybody that's made it this far. We've got our general schedules here. I should have changed that pipe material specification. Doesn't match what I ended up designing, but anyways, these are kind of general. They're not really specific to this project. Here's an overall view. So you want to size your septic tank, of course, on multiple different things. There's code requirements, but then there's also recommendations from septic tank manufacturers on the size you want to go with and the interval to have it cleaned out. So the bigger your tank, the less you need it cleaned out, of course. That's why I went with the 2500. I was going to go with the 1500 because it was the code required minimum size, but if you're going to go ahead and have one installed, you're paying for the installation and everything. So the material cost to go ahead and just upsize it a little bit. It's not that much in order to save on the cost for having it cleaned out. There wasn't really much of a cost difference when I did a cost analysis of the two, so I decided to go a little bit bigger. This is just a basement of all your plumbing. There's not too much you probably want to see here other than seems like it's having some technical difficulties here. Okay, there we go. So you got your storm drainage coming down here outside. You got your cold water inlet coming into the house. You got a heat pump water heater here, and then you want to insulate all your hot water lines with like 1 inch of foam insulation or fiberglass insulation, whatever you prefer. And then also your cold water lines you want to insulate within I think the energy code requires any pipe within 10 feet of the water heater to be insulated. And then along your eastern wall here, we've got the pump, the water pump that will pump from your cistern and provide water to the whole house with an expansion tank. The expansion tank just provides a buffer for the water pump so it's not kicking off and on constantly. And then you've got a filtration system set up as here as well. I'll go over the filtration system in just a moment. Okay. This is your first floor, not too much you want to really see here. You want to make sure and have a filter on all of your downspouts and also a downspout diverter in order to minimize the amount of sediment and organic matter that enters your cistern. Got outside air intake here, which we've already looked at. And then you've got, of course, all your plumbing fixtures. Not much to see. Most all the plumbing is underneath the floor down in the basement, so there's not really much to see up here on the first floor. But you got, bathtubs and toilets and lavatories and kitchen sinks and dishwashers, and of course your laundry, your washer and dryer. Then you got some clean outs for your sanitary sewer system. And then up here in the attic, not much to see here. You got a plumbing vent going out and your radon vent going out. Then we went ahead and put together a few isometrics. This is of your domestic water system. So this is where the water comes in from your site, from your cistern. You want to have a shut-off valve there. The first 3 filters are spin-down filters, and they decrease in size of particles that they'll allow through. So that's in the plumbing schedule. And then your final filter here is a 1 micron filter, and that's because your F5, which shows up on electrical because it's an electrical fixture as well. F5 is a UV filter that will kill any bacteria. It actually doesn't kill it, I was reading it. It sterilizes it, so the bacteria cannot reproduce, and I guess other viruses and bacteria. So anyways, that's your system setup. I left those generic as well. I just specified the filter size, the mesh size, and then of course you got your sanitary sewer system. And we have a few details of your downspout diverter. Your downspout diverter will want to have a small hole drilled in it, a weep hole, so that it empties slowly. You just want to get the first flush off your roof into that diverter so that all the leaves and everything don't go down into your cistern. Let's see, next we go on to structural. These are just some details from the International Residential Code. You'll want to refer to the International Residential Code for all your structural design. And these are just schedules of all the materials that you'll need. And then these are the structural plans. Of course, you can see on the basement, you just have a slab on grade with you got a foundation below, and based on the location that I'm looking at, the 16-inch wide by 8-inch wide was more than sufficient for the foundation. And then we got CMU walls for the basement, and then the first floor we've got slab on grade on both sides, and then we got 2x10 structure in the middle where we got the basement, and then of course we've got our CMU walls that go up. And also on the exterior of the house we have just a 2x4 frame. Really the only purpose that serves is to hold up the metal siding, and also to hold up the structural supports for your solar panels. And then of course we have the roof structure, which is in, oh I'm sorry, this is the second floor structure. We have of course the CMU walls are the main structure, and then that supports the engineered trusses for the second floor. And then the roof structure is engineered I-beams setting on top of your CMU structure. And depending on your manufacturer's recommendations, I think we got 12-inch spacing for the engineered trusses and 16-inch spaces for the engineered trusses, and 18-inch spacing for the engineered trusses, and 2-foot spacing for the engineered I-beams. So that was one cost reduction method, was to replace these trusses with I-beams. I may end up taking that up. It's nice to have that space to run your utilities, but you can always knock out spaces in your I-beams as well. And then we laid out your CMU here for you. Tried to keep everything. That was one cost savings measure or constructability measure we took, was all the windows have standard sizes. They're all 4 foot by 4 foot, or on the side we had to go 2 foot by 4 foot in order to get one complete block in between the door and the window. But if you keep them the sizes of the block, the blocks are 16 inches by 8 inches. So if you keep them within those dimensions, then you won't have to go through and cut up a lot of block and put in a lot of specialty block or anything. Just make it a little easier for the masons. And then we got some elevations of the framing. This is just kind of general elevations to give you a general idea, but the framers will end up probably framing it up however they see fit, as long as it meets the requirements to support the siding, and there's code requirements for walls as well. So as long as it meets all the code requirements, that's all you really have to worry about. This is a section view of the solar panels. You can see up here where we got the wall packs, and then we mounted our CCTV right below the solar panels in order to protect them from the weather some. That's another purpose for the solar panels here, is that'll create like a porch area. I'll put flashing in between all the panels so that they block most of the rain coming down, and that way you'll have a kind of a makeshift porch on the front if you'd like. You can see your outside air intakes. Tried not to block any windows or doors with the supports, but of course we failed on a couple of them. But it's 3 panels per support stanchion, and it's all off the shelf unistrut, so it shouldn't be an issue to find any of that. And this is kind of in detail here. You can see that the angle changes. There's a couple websites you can go on, and it'll tell you the angles that you can use. Those are in the reference spreadsheet that's also included with the download package for this design. So you'll have to change that depending on the location, because every location, if you go with adjustable solar panels, like I said, the cost analysis, it probably doesn't justify having adjustable solar panels. You're probably better off just going with a fixed solar panel, and plus it's probably a little bit more robust structurally. And then I found some standard details for how to support the second floor off of some concrete walls there, and I'm sure there's code requirements as well that'll have to be met, and then a couple isometrics for the structural design, and we got a bill of materials here for sorry about that. I've got a bill of materials for the solar panel supports with all the unistrut part numbers. Of course, I'm sure there's other manufacturers out there that make similar products. And then, kind of an idea of what your different floors will look like and your roof. And that's it. There should be pretty much everything here needed to build a house. I guess now it's time to take a short coffee break, and then we'll go over the design.